Alright, so I think I'm recording. This is the last problem of this assignment where we're looking at polynomial functions, trying to find the x-intercepts, the zeros of the function, also called the roots of the function, by using this rational zero theorem. Here we have a third-degree polynomial expression that we don't have. We don't have any technique that would work in factoring this, so this rational zero theorem might provide us a way to factor this. Of course, it might not as well, because it only confirms rational zeros, not irrational zeros. So the theorem tells us to look at the constant term and look at the leading coefficient and to look at their factors. So the factors of -8 plus or minus 1 plus or minus 2 plus or minus 4 plus or minus 8. The leading coefficient is 1, so that's just plus or minus 1. So my list of possible rational zeros are 1 plus or minus 1, 2, 4, and 8. So now the search begins to attempt to find a x-intercept. So we know on an x-intercept that y is equal to 0 if you're on the x-axis. So if you plug any of these into the function and calculate it and get a 0, then you know you've found an x-intercept. But then after you found it, you'd have to do synthetic division anyway, so I just go ahead usually and just jump right in and do synthetic division in search of a 0 remainder. So I've got 1. Now, initially I should have commented that there is no greatest common factor to this original polynomial function, and it is in standard form, and it has no missing terms. It has a cubed term, a squared term, a linear term, and a constant term. So I don't have to introduce any zeros for my synthetic division. So this guy is, I do not find a 0 remainder, so I know that x equals 1 is not a 0 of the function, so I keep searching. Try -1. And we found it, or we found one of them. There may be more, but we found one, and since this is third degree, when I find one now from my result, my synthetic division, I have a quadratic, and with quadratics I don't have to continue. I could continue the synthetic division if I wanted to, but with the quadratic I'll just either factor it or use the quadratic formula. So what this tells me now, this original third degree polynomial, that I didn't have any method to factor this, but now with this rational zero theorem, sometimes it helps us to factor if it has rational zeros. So if x equals -1 is an intercept, is a 0 to function, in factored form we write that as x plus 1. And now from the synthetic division, that 1 is 1x squared plus 2x. See, I'm just using the coefficients, and now minus 8. So to find the x-intercepts, you let y equal 0. And since this is negative and that's positive, my two factors, one is positive, one is negative. The middle term is positive, so the one larger in magnitude is going to be a positive value. So that's plus 4 and minus 2 should work. So it was the third degree, and I just found 3 zeros, so I have found them all. So it turns out all of those are rational numbers. Now let me show you something else. You can stop the video if you'd like, but here's suppose I had kept going. Suppose for whatever reason I suspected that there was more than just -1. I can come in and let's jump to, let's say I tried 2 next. I can just use this 1, 2, -8 and do synthetic division with the 2, and since I know that this is going to give me a 0 right here, or it should. 1, 2, 4, 8, 0. So what does this tell me? Well, you know, here I'm going to use this previous work to to illustrate what that tells me. The first time that I did synthetic division, it allowed me to factor it the first time. So this 128 helped me here. Alright, well now when I if you look at 1 and negative 8, well here still 1 and negative 8, it still has the same leading coefficient and the same constant term, so it has the same list. So sometimes you'll have a repeated. I could have tried negative. Sometimes there'll be a repeated root. Could have tried negative 1 again and got a 0. But I cheated a little bit and I looked at the answers so I wouldn't have to waste time in search. I tried a 2 on this 1, 2, and I looked at this quadratic function and said, hey, let's do synthetic division using 2 and see if we get a 0 remainder. So that tells me this guy, if x equals 2 is a 0, then in factored form that's x minus 2. And then here the 1 and 4 tells me this is the remainder, the constant term, the linear term, and that tells me 1x plus 4. So I get the same factors and therefore the same x-intercepts, the same zeros of this function. And I never did factor with any kind of x method or anything. I just used synthetic division twice. So I always thought that was kind of neat. Very helpful if you know that you have a repeated root, because then you can do the same on the synthetic division, and it whittles it down. You know, since this is now a remainder of 0, you don't use that in the next synthetic division. So I hope that helps. Anyway, talk to you later.